Okay, so just so we've got a recording of what we did about distance, midpoint, gradient in the last class. Okay, so we've got 2 points, x2, y2 and x1, y1. Just to remind you that these are just called subscripts, and they just refer to the second x and the second y, the first x and the first y. So we've got some plug and play formulas that you might have known from last year. So the distance equals x2 minus x1 squared plus y2 minus y1 squared. Gradient is the rise over the run, y2 minus y1 over x2 minus x1, and the midpoint is just the average of the points. So let's look at some examples on the next page when you're ready. So first one's just straightforward. Now this is just one method that you could use. So what you do is you just do your calculations on the side, and so rather than necessarily just putting them into the formula, okay, so I put the first point and the second point on, and two of the formulas have minus signs, so I'm just subtracting 1 minus 3 is minus 2, 4 minus 1 is 3, so I'm going to use those two numbers. They're not coordinates, they're just numbers, and I also need to add the numbers for the midpoint, so I'm just going 1 plus 3 is 4, 4 plus 1 is 5, so I'm going to use those in a sec. So the distance now is just that number and that number, and we just square them. A negative squared is always a positive. These numbers are always positive. Okay, you can't square a number and get a negative, and then you just add them together. 4 plus 9 is 13. With the gradient, that number is your y values, and this number is your x values. So we just put the y over the x, and then obviously you could leave it as minus 3 on 2. Probably better not to use decimals, get too messy, but minus 1/2 is also acceptable. And the midpoint is when we use the 4 and the 5, because we're adding the numbers, and so we just put 4 and 5 and we have to average them, so we divide by 2. And again, this has to be cancelled down. 4 over 2 equals 2, but 5 over 2 could be left as 5 over 2, or you could take it to 2.5. Best not to do decimals because they get too messy. Okay, so copy that down and we'll do another example when you're ready. So this time I'm just trying to put in some negatives, so you've just got exposure to negatives again. So just again, this is just the way you could do it. So I set up a minus, I set up a plus, because I'm going to use minuses for distance and gradient, and I'm going to use plus for midpoint. So I'm just subtracting minus 5 minus 0 is minus 5, 3 minus minus 4 becomes 7, and on the adds, minus 5 plus 0 is minus 5, 3 plus minus 4 is minus 1, so I've got to use those numbers. So in the distance, I'm just going to use those numbers and square them. Minus 5 squared and 7 squared end up with 74. The gradient is just going to be 7 over minus 5, which is minus 7 over 5. Let's bring the minus sign up. And if you want to, you can make it minus 1/2. Again, prefer not to have decimals. Most books will not have a decimal answer. And in the midpoint, you've just got those two numbers, and you just stick them over 2, and you don't have to change them, although some of you will probably prefer that. But again, please don't use decimals. So that's the OR answer. Okay, so copy those down, and let's have a look on how you might use them. I'm not sure if the textbook goes into these depths so far, but you'd be expected to be able to do these next things. So come across when you're ready. Okay, so when you've got problems, we can definitely use distance and gradients to show many things. So it's just an example. I'll just bring it up a little bit higher. Gone too far. Okay, so if you need to prove that 4 points make a square, you have to do two things. You've got to prove that the distances are all the same, but adjacent sides, like if I've got a square, so those two sides have to meet at a right angle, okay? And theoretically you'd have to keep going all the way around, so that's not going to be quick. But once you've got the gradients, once you've got this gradient, yeah, you've really got to go right around. You have to find the 4 gradients and then prove that M1, M2 and M3, M4 have a minus sign when you multiply. If you need to prove a rectangle, basically the same, except you have to have opposite sides have to have equal. So in squares, all sides are equal. In a rectangle, opposite sides are equal. Again, with a rhombus is just a square pushed over, and a parallelogram is a rectangle pushed over. So similar to the square and the rectangle, either all sides or opposite sides have to be equal. And then rather than being perpendicular, so with a parallelogram, you've got to prove that those two are parallel and those two are parallel. Okay, so you've got to do two sets of gradients. So copy that down, come across the next page when you're ready. So with triangles, similar thing. If you want a scaling triangle, all the lengths are different. If you want an equilateral triangle, all the lengths are the same. If you want isosceles, you need two are the same, but the third has to be different. And with a right angle triangle, it's a little bit harder. The three side lengths have to fit Pythagoras, or, you can do the or, two sides, the gradients are perpendicular. So if you can prove that M1, M2 are perpendicular, then you have a right angle triangle. And the 3 points are going to meet, so they have to form a triangle. But if you can prove that M1, M2 equals -1, you have a right angle triangle, so you don't have to worry about lengths, but the lengths might be quicker. Okay, I think, so the textbook exercise is on straightforward, and I'll see if I can find something about the geometry side and put that up on Moodle as well. So thanks for coming.